Okay, so today we're going to talk about transformations and symmetry. That's chapter 7, and we're going to be doing some neat artistic projects when we start dealing with some tessellations. And so first of all, today we're going to talk about transformations. So the definition of a transformation is a rule that assigns to each point of a figure another point in the plane called its image. And that's what a transformation is. And so if we look at the next slide, we talk about a rigid transformation. So we have two classifications of transformations, rigid and non-rigid. So a rigid transformation is also known as an isometry, and that's what you really need to understand. It's known as an isometry. An isometry is a transformation that preserves size and shape. So the image is congruent to the original figure. It preserves size and shape. So that means whatever you do to the figure, it stays the same size and it stays the same shape. So we have three types of rigid transformations, or three types of isometries. And those are what we're going to focus on today. A translation, a rotation, and a reflection. And what we're going to do is break down each of these three and look at these three individually. But these are the three types that you need to know. A translation, a rotation, and a reflection. And you've seen all of these before. This should be nothing new. Okay? So, all three of those preserve size and shape, and the image will be congruent to the original figure. Okay, so then now we have what's known as a non-rigid transformation. A non-rigid transformation is a transformation that does not preserve size and shape. So basically the image is reduced or enlarged. So when we think of a non-rigid transformation, we mean it's either shrunk down or it's gotten bigger. So it does not preserve size and shape. Okay, so that is what a non-rigid transformation is.
What?
Okay, so now what we're going to do is we're going to look at, oops, it skipped. We're going to look at a translation. So first of all, a translation is an isometry in which each point is moved the same by the same translation vector. Okay. We also call a translation a slide. So basically what you've done is you've slid the image in any direction. So notice we have what's known as a translation vector here. That's actually the vector, how it's slidden. So we've slid here from the black to the blue. We have a translation with the patty paper where you start with two of the same shapes. You just move the other one. And then translations on a coordinate grid basically means that you're going to translate them. In this case, what we're going to be doing in that first one is we're going to be going over 1, 2, 3, 4, 5. So we've went over to the right 5, and how far up have we went? 3. So that would pretty much be like an x plus 5 and a y plus 3. Okay, on this one, what have I done here? On this one, if you notice, I went from f to f prime. If I look at that one, I've went what? Back how many?
-5.
So that would be like x minus 5. And then what have I done to the y? Down 1, 2, 3, 4. So that would be y minus 4. So that's pretty much what you've done. And so you can translate that way as well. The next one we're going to look at is what's known as a rotation. A rotation is an isometry in which each point is moved by the same angle measure in the same direction along a circular path about a fixed point. Okay? So it's kind of a wordy definition, But what it means is that you've got a center of rotation. And so you imagine that that figure is along the arm of a clock, and you're going to rotate that along. That's the easiest way to think about it. Think about the arm of a clock, and this is here, the center of the clock. So imagine that you have like an invisible line right here that's holding that, and this is a clock that's ticking as it goes around. Okay, what is that figure going to look like when it is rotated that specified number of degrees? And so you can model a rotation by tracing over a figure, then putting your pencil point on the patty paper and rotating the patty paper about the point. So that's what I talked about when I said the clock hand. Because here you have the center of the clock, and then what you've done is draw up your clock hand. And so it's just like it ticks, tick, tick, tick. And then what is it finally going to look like? Okay. The rotations are honestly the hardest ones to visualize. So the best way to visualize it using the mentality of a clock. A reflection. What is the first word that comes to mind when you think of the word reflection? Mirror. Mirror. It's exactly right. It's the mirror image. So a reflection is an isometry in which every point of its image and its image are on opposite sides and the same distance from a fixed line. So it's the mirror image. That fixed line we have a special name for. We call that fixed line the line of reflection. So basically what we do is we take an image, we have a line, and we basically fold over the image on that line. And so now what I'm going to need you to do is I'm going to need you to turn in your book to page 370. So when you get that down, I need you to turn in your book to page 370. On page 370, you're going to notice there's an investigation. And I've went ahead, and here's the investigation. I've given you a sheet of patty paper. What I need you to do is I need you to go ahead and complete the investigation and then fill in what you think the reflection line conjecture should be, or just talk amongst yourselves. What we will do is we'll come back together then and we'll talk about what goes in the blank and we'll fill it in. So,
you can draw anything?
You could, any sort of polygon, yes. So now you should have completed your investigation, and so now we're going to look at the reflection line conjecture. It says the line of reflection is the blank of every segment joining a point in the original figure with its image. Okay, so what did you notice?
Bisector.
It's the bisector, but it's also even a little more specific than that.
Perpendicular.
It's the perpendicular bisector.
Dang it, I don't have enough room.
Okay, so remember you could abbreviate perpendicular with an upside down T if you needed to squeeze that in there. But the line of reflection is actually the perpendicular bisector of a figure. All right, now, just a little tidbit. And I don't know if you caught this on the congruent thing. When we draw a figure in its image, okay, so like if I draw a figure here, I would call this like figure ABC, right? And let's just imagine I drew in a line of reflection here. And then I draw in this figure here. In order to draw its image, we use what are known as primes. They're little like apostrophes. And so this point would be C prime. This point over here would be what?
A prime.
A prime. And this point over here would be B prime. And it's important you understand that because that will tell you if it's going to be a slide or a reflection. Okay, because I could make this a slide.
It might be.
If I made it a slide, this would actually be point A prime, this would be point C prime, and that would be point B prime. Okay, so that's why it's important that you understand what the primes mean. So let's go ahead and look at the next slide. Reflectional symmetry is also known as line symmetry. You see line symmetry a lot of places. And basically, if we think about line symmetry, that's if we could draw a line in a figure, it's going to be the mirror image on either side. So if I look at this Navajo rug, where could I draw a line in so that that would have line symmetry? Right down the middle. So if I drew a line in right here, right down in the middle, that rug is going to be identical on both the left and the right of that line. Is that the only line of symmetry that would work there? Where would be another line? The horizontal line, right. If I would cut it right here, right down the middle here, it's going to have horizontal line symmetry as well. So I want you to think about a square. I have a square here. I want you to think about how many different lines of symmetry could I draw in a square. How many different lines of symmetry could I draw in a square? So with that in mind, I want you to go ahead and you've got your expressions. I want you to enter a number. How many lines of symmetry could you draw in that square?
These very small box.
I had to turn my right on.
So let's see what we got. 4. Nice job. How'd you get 4?
Well, there's 2 diagonals and then one up and down and one side to side.
Okay, so I heard somebody say vertical. I heard somebody say horizontal. What's the other ones?
Diagonals.
Corner.
Diagonals, corner to corner, right. Oops, that one. Okay, so there are actually 4 different lines of symmetry. Nice job. So the next one we're going to talk about is rotational symmetry. Now if you look at rotational symmetry there, let's look at the one on the left. My original figure has been rotated how many times around?
5.
5. Okay. So what I've done is I've rotated that figure around 5 times. This one, notice the birds. It's been rotated around 4 times. Now if I think about the center of rotation, where would the center of rotation be here on the left?
The middle of the pentagon.
Right in the middle. That's where it's going to rotate. It's actually going to rotate around. Okay. Where's the center of rotation going to be here? In the middle here. So remember what we think about when we think about a center of rotation. We think about the center of a clock and it just rotating around. Okay, next question. The figure below is A. So this is going to review from what we talked about earlier. There you go. What is that figure? Good. It's a rotation. Nice job. Okay, with that in mind, let's look at the next one. What is this figure?
Let's go, Katie.
I said it.
Good. It's a reflection. Nice job. And last but not least, what is this? Oh, just a second. Sorry. I'm sorry I didn't send that right away. That's my screw up.
Oh, dang, I sent the wrong one.
Katie. Well, we know which one is going to be wrong. Katie's.
So this one is actually
Katie
a
put me
translation. Okay.
I didn't.
So now your assignment is found on pages 372, 373 in your book. It's 1 through 14. It'll be due tomorrow at the start of class. So.